So let's look at an example using Mendelian randomization. In this example, we're going to look at a biomarker called C-reactive protein, or CRP, which is a biomarker of inflammation. So CRP is observationally associated with BMI, metabolic syndrome, coronary heart disease, and a number of other diseases. However, it's unclear whether these observational associations are causal or whether they're due to confounding or reverse causality. And this is a really important question, particularly from the perspective of drug development. So if you're a pharmaceutical company, you want to be very sure that C-reactive protein is causal for these diseases before you invest millions of dollars into developing agents to target CRP. Because if CRP is not causal, then it doesn't matter how much you intervene on it, it's not going to affect your risk of disease. So Mendelian randomization is one method whereby we can gain information on whether CRP is likely to be a good drug target. So in this example, we're going to be a little bit clever, and we're going to do something called bidirectional Mendelian randomization. So this is basically testing for causality in both directions. So we're going to look at the relationship between body mass index and serum C-reactive protein levels, and we're going to do Mendelian randomization in two ways. So first of all, we're going to look at whether there is a causal relationship between CRP and BMI. So we're going to proxy serum CRP by using a genetic variant in the CRP gene. And so we're going to do Mendelian randomization, looking at whether CRP causally affects BMI. But we're also going to instrument BMI using a genetic variant in the FTO gene, which we know is robustly associated with body mass index. And so we're going to do MR in the other direction as well to see whether BMI causally affects levels of CRP in the serum. So let's first of all look at whether BMI causally affects CRP. If we were to do a simple observational regression, so let's say that we regress CRP levels on BMI, we would get an estimate of about 1.075 with some very tight confidence intervals. So that corresponds in the diagram below to these two very tight black lines here. When we do our Mendelian randomization analysis, or our instrumental variables analysis, we get a very similar estimate of 1.06. So that's this white line here, which is very close to the black lines. The confidence intervals indicated by this gray shading are a little bit wider, and that's a consequence of IV analysis and Mendelian randomization being less powerful than ordinary least squares regression. Indeed, the p-value on that instrumental variables estimate is highly significant. And we can do a test of whether the two regression coefficients are significantly different from each other. So is the IV estimate different from the observational ordinary least squares estimate? That's telling us no, it's not. And finally, this last column is what's called the first stage F statistic. So this is just the F statistic from the regression of BMI on the SNP that's proxying BMI, so FTO in this case. And that's telling us that there is a strong association between the two. So this is kind of important to assess whether the instrument for BMI in this case is what's called a strong instrument. So basically you want that first stage F statistic to be above 10. Otherwise you could run into a problem called weak instrument bias, which we'll talk about a little bit later. So all in all, these results are telling us that there is quite strong evidence that BMI causally affects levels of CRP. Let's look at the reverse now. So now BMI is our outcome, and we're looking to see whether CRP levels causally affect BMI. So again, if we were to just regress BMI on CRP levels, we would get an observational regression coefficient of 1.58 with these confidence intervals. So that's again these two black lines very close together. However, when we do our Mendelian randomization analysis, the IV estimate is very different from that. It's minus 0.3 with these wide confidence intervals. So that corresponds to this white line with the gray shaded area representing the confidence intervals. That MR analysis is not significant, and there's strong evidence that the IV estimate and the observational regression estimate are very different. Again, we've got a very strong instrument for CRP, so that's telling us that the variant in the CRP gene is a strong instrument for CRP. It's way above 10, so that's all good. But these results in general are saying that CRP is not causal for BMI. So it looks very much like the observational association between CRP and BMI is actually due to BMI influencing CRP levels and not CRP influencing BMI. So that's an important message if you're a pharmaceutical company, because it suggests that there's nothing to be gained by developing agents that affect CRP levels. It's not going to do anything to your BMI.